Here we go, everybody. So let's do a quick reminder of our whole body listening. My kids at school, not home. See, I caught myself. Ears are listening. So your brain's thinking about what is being said. Eyes are looking. Mouth is quiet. Hands and feet are down and still. And so today we are going to be reviewing a little bit, and then we will work more on problem solving. You'll find your lesson under math today. Today's Wednesday, so it's lesson 5.9. So our learning target is to solve word problems requiring 2 steps. And we're going to be solving 2-step word problems because that's what most word problems really are. You'll be able to review the properties of addition and multiplication. We did that with our morning graph today. And then we're going to write equations to solve 2-step word problems. All right, so who can remind me about commutative property? Remember, it applies to addition and multiplication.
Numbers around and
Hold on, don't do anything with it, okay? Because I'll lose it. Okay, say it one more time.
If there's 2 numbers in a problem, you can switch them around either way, and it still equals the same stuff.
So she said it doesn't matter which order, it can be different orders and it'll still equal the same sum. Just like 40 plus 50 equals 90, 50 plus 40 equals 90. But it also works for multiplication, right? 3 times 4 equals 12 and 4 times 3 equals 12. It doesn't matter the order of the factors, the product remains the same. Okay, now let's look at identity property of addition. If 0 is added to a number, the sum equals that number. I want you to write down an addition problem where you pick any number and add it to 0 and tell me what you get. Write it in your math spiral. Everybody at home, write an addition equation where you're adding a number to 0 where you get the same number. Go for it. In your math spiral. I think that sounds better. Just because I'm the host, do you hear it?
I just hear like you talking now.
Yeah, I turned that off. All right, let's hear from, how about Reese? Can you give me your equation? Any number plus 0 should equal that number. That's the identity property for addition. Reese, do you have an example that you could share?
2 plus 0
Equals what? What does 2 plus 0 equal?
It equals 2.
Any number plus 0 is that number, right? Robert, what did you write down?
I write it 64 plus 0 equals 64.
Robert wrote 64 plus 0 equals 64. Lucas, what did you write? 8 8 plus 0 is 8. Ellie.
2,896 plus 2,000 plus 0 equals 2,896.
2,896 plus 0 equals 2,896. How about Ben? What did you write, Mr. Bowers?
I wrote 100 plus 0 equals 100.
You wrote 100 plus 0 equals 100. Awesome. Okay, so that is a just quick review of the identity property of addition. Commutative, I feel like we have talked about so much that you guys get that. The whole reason I'm bringing this up today is so that when we are problem solving, you can use these properties to help you find the answers. All right, so we're going to review 2 more. And my goal is not for you to memorize them necessarily, because some of you can't even pronounce them. They're hard. They're hard for me. The goal is for you to learn. Abby, can you come sit right here? For you to learn a tool to use when you are solving word problems. So let's look at identity, the 0, and then we'll look at associative and distributive. I think it's just amazing that 3rd graders are able to learn all of these properties. I did not learn all of these at your age. You guys are rock stars. So here's the identity property. The product of 1 and any number is that number. Do you remember when we did that when we multiplied with 1 as our count by? Any number times 1 is that number. So I did my example with 37 times 1 equals 37. Can you do an example as well? If you have time, do more than 1. On your mark, get set, go. See how many you can write, Finn. Ready? On your mark, get set, go. How many equations can you do that show the identity property of multiplication? You're writing examples. Any number times 1. Can be any. 5 times 1 is 5. 256 times 1 is 256. What are you going to write down? You get to decide. Go for it.
We just need to know if the sisters are getting car pickup today.
Oh, I see some big numbers. Oh, some of you are venturing into the thousands place. Holy moly. All right, Jensen, can you unmute and share one of your examples for the identity property?
I did every single number times 1.
100 times 1? Okay.
Yeah.
And 100 times 1 should equal? 100. Awesome. Henry, can you unmute and share yours?
0 times 1 equals 0.
Oh, wow. Okay, so you actually did the 0 property. Can you pick a number besides 0? What's another number you can multiply times 1? That still works. Can you pick another number? How old are you, Henry?
7.
Oh, 7 times 1. What is 7 times 1, Henry?
7.
Excellent day. All right, share with your neighbor one of your examples for the identity property. I need you to keep your cameras on. Please keep your cameras on. Thank you. All right, now we're gonna do the zero property of multiplication. If zero is multiplied by a number, the product is always zero. I chose 250. Oh, you get to use one time. It's okay. All right. 250 times 0 is 0. Now you guys can come up with your example. It doesn't matter how big the number is. If you multiply it by 0, it's still going to be 0. The product will always be 0. That is the zero property of multiplication. Go ahead and see how many examples you can write down on your mark. Get set, go. Any number times 0 is 0. So pick any number you want and multiply it by 0. Time, make sure it's in time. You okay? Any number times 0 is 0. So this is 0, not that number. As I come around, I see some confusion between the two properties. Remember, if you're multiplying by 1, it's that number. But if it's by 0, it's always 0. You can't have anything, right? You're multiplying by nothing. Total equals 0. Okay, can you tell me something else that we could read, remember?
And you read your book? That was on my study.
Still equals, yeah. All right. Any number times 0 is 0. So we're writing this paper. Minus 250 times 0 is 0. All right. Abby wants to share hers. Abby. So
100 billion times 0 equals 0.
how much?
100 billion.
Oh, 100 billion times 0 is 0. Okay, go ahead, my dear Haley Booker.
Can I just say all the numbers because I don't know how to read them?
No, it has to be something you can read. We'll come back to you. Paxton, a number you can read.
Infinity times
Okay. A number you can read. Robert.
9,009,999 times 0 equals 0.
9,999,999 times 0, 0. Something like that. Okay, let's hear from my friends at home. How about who? Astria, what is your example?
50 times 0 equals 0.
50 times 0 equals 0. Excellent. All right, we're going to watch the videos for a quick review of, say it with me, associative. Ready? Associative, and then distributive. Distributive property.
Hey kids, thanks for joining Pink Parentheses and me today. We are learning more about multiplication, specifically what we call the associative property of multiplication. We would like to get your help. Will you help us? Great, let's get started.
Great.
The associative property of multiplication says when you are multiplying several digits, you can regroup or reorder the numbers, and the product will stay the same. Here we have an example of this concept. 3 times 4 times 2. We are multiplying 3 digits, but where should we start? We could start with 3 times 4, or we could start with 4 times 2. The associative property tells us it does not matter which way we do it. We can choose which group of numbers we start to multiply. That is kind of cool. I want to start by multiplying 4 and 2. This gives us 8. Now we have 8 multiplied by 3. What is 8 multiplied by 3? The answer is 24. Great job. But now I want to try the other way, so let's clear the board. We will start with 3 multiplied by 4, which gives us 12. Now all we have left to do is multiply 12 by 2. 12 times 2 is 24. We got the same answer regardless of which numbers we started multiplying together. This is awesome. Let's look at another problem and see what we can do. This time our friend, King Parentheses, is helping us group numbers by putting a parentheses around 2 of the numbers. We can see that we have the same problem on both sides of the board, but with the parentheses grouping different sets of numbers. We learned before that both of these problems should come out to be the same answer or product. King Parentheses just told me that I forgot to tell you something important. Whenever you do a math problem that has parentheses, you need to do what's inside first. Remember, the King Parentheses comes first in math problems. So when we work this problem, we need to multiply the numbers in the parentheses first, even though the answers will still be the same. Thank you, King Parentheses. We will start with the problem on the left. Remember, the king goes first, so let's multiply 2 by 2. We get 4. And now all we have left to do is multiply 4 by the last number, which is 5. What is 4 times 5?
Nice job.
If you said 20, you are correct. Now we can do the problem on the right side of the board, and if the associative property of multiplication is right, we should get the same answer.
So what should he get?
To start, we remember the king goes first, so we multiply the numbers in the parentheses. 2 times 5. The answer to that is 10. Now all that is left is 10 multiplied by 2. What is 10 times 2? 20. Great job, kids. We can see that both problems give us the same answer no matter how we group the numbers.
What does that remind you of? What property does that remind you of? Which one? What do you think? What property? Yeah, me too. It reminds me of commutative because why, Cerny? What do you notice? Finn. August comes over here. Yeah, the order can mix and you still get the same product. Now, what if those parentheses weren't there? What could we do? Keep going, Cerny. Abby, stop.
You can choose which group of numbers you want to do first, and then add the next number.
Yeah, it doesn't matter. I could choose to do 2 times 5 or 2 times 2 first, and then multiply by the next factor. It doesn't matter. I'm still going to get the same product, which is pretty cool. And when you're doing 2-step word problems, the whole reason we're looking at this is because you might have to do 2 steps of multiplication. And here it's telling you, use whatever order you want. You'll get the same answer.
This is amazing stuff. Thank you so much for joining us today.
All right.
The king and I have to get going, so we will see you later.
Yeah.
All right. Okay. So now, distributive is another, it is definitely a property you guys use already. It just sounds scary, and the shark makes it look scary, but you guys use this. And I think you use this better than any class I've ever had. So when you watch this, you'll say, oh yeah, I used distributive property. I just didn't know what it was called.
Hey guys, I came in here looking for the distributive property of multiplication, but I had no idea these guys were in here too. I am being chased by number-eating sharks, and I am one of the tastier numbers around, so you can imagine how scared I am.
1. You don't do that.
Why don't you guys learn about the distributive property of multiplication while I lose these guys? Sound good?
Okay.
Thanks. See you back here when you're done. The distributive property helps us find a product that we don't know by breaking larger factors into smaller factors. This can sound a little scary, but once we understand it, we will see that it is not that bad. Here we have the problem 7 times 7. I still struggle with multiplication, so I am going to use the distributive property to make this easier to solve. We are going to take this 7 here and break it apart into 2 smaller numbers. The distributive property only allows us to break apart one of the factors in an equation. 5 plus 2 equals 7, and we can now multiply each of these numbers by the first 7 in the problem. I know that 5 times 7 is 35 because I know my 5 times tables. I also know my 2 times tables, and 2 times 7 is 14. What we just did was take the first 7 in the problem and multiply it by both the 5 and the 2. I did not know my 7 times tables very well, but by breaking the numbers apart, I was able to solve these 2 equations. Wait, are we done yet? No, we still have to finish the problem. In order to get the answer, we need to add the 35 and 14 together. 5 plus 4 is 9, and 3 plus 1 is 4. Wow, 49 is the answer. That is awesome. So 7 times 7 is 49. Even though we did not know our 7 times tables very well, we solved the problem by breaking apart one of the factors into numbers we knew how to multiply. Then we added the 35 and 14 together and got our answer. That is amazing. It looks like the sharks want us to try another problem. Here we have 8 times 6. Let's break apart the first factor, the number 8. There are several ways to break apart 8, but I want to use 5 plus 3 because I know my 5 times tables. We now need to multiply 6 by both the 5 and 3. I know that 5 times 6 equals 30. What does 3 times 6 equal? 18. Great job. We now need to add the 30 plus 18. 0 plus 8 is 8, and 3 plus 1 is 4. 48 is the answer. 8 times 6 equals 48, and we figured that out using the distributive property. We were able to find the product or answer to a multiplication problem by using the distributive property. Can you see how using this method can help us answer hard multiplication problems? Wow, thank you guys so much for joining me. I was able to lose the sharks and all is good now. We will see you next time. Goodbye. Something? Probably nothing.
It's division. Division.
All right, so how many of you, and I'm going to come back to my kiddos at home, give me a thumbs up if you guys use distributive property. But if you don't know one of those hard multiplication facts, you break it up, especially with your 5 3-stars. Yeah, I know a lot of you do. Astria, it's on our review. Henry does. Katie, do you? Yep. Ben, how about you, buddy? Ben.
Haley is
He's
in
either
the.
sleeping or frozen.
I think
Jensen, I've asked you to keep your camera on. Please do so.
Haley's in the waiting room.
Oh, can you? Oh. That's okay, I got her. All right, Jensen, I need to see you, buddy.
Gavin is in the guest.
All right. And stand up if you use that in class. If you're here in class, stand up if that's one of the strategies, the properties you really like distributed. Stay standing if you like commutative, where you can flip it around, it doesn't matter the order. That is my absolute favorite property of all. Awesome. Now, how many of you sit down if you think you're willing to try the associative property, where 5 times 3 times 2, you can multiply in any order you want, unless there's parentheses.
I'm going to try that.
Have a seat if you're willing to try it. I hope everybody sits down. Okay, good job. So that was a quick review of our properties to help us with what we're used to doing in this unit. We only have the rest of this week for this unit, and then we go into geometry with shapes. So I want you to really pay attention because we're going to be practicing those 2-step word problems. Lena, no ma'am. Nope, sit down and give me whole body listening. We're not leaving right now. Okay, thank you. We're not getting up to go. Put it to the side, please. It is time for math. So we're going to read the problem. You're going to visualize or picture it. You're going to retell it and look for clues and draw a picture, find the unknown, and then we will reflect. What we've been doing all year long, right, to make sure we're successful. This was our graph yesterday. Show me on your fingers. Which, I'm going to read one of these. You got to show me the symbol. All right. When you know the total amount and you give it away, whether it's you eat it, you spend it, but you get rid of it altogether. You don't have it anymore. Show me on your fingers which operation that is. Show me on your fingers. Lucas, I'm waiting. Show me on your fingers. What? You're not with me. Stay with me. Cooper, what is it? It's subtraction. You know the total and you're giving it away. Okay, what if you don't know the total, but you need to find it, like they want to know how many altogether, and it's the same number again and again because they're equal groups. Which operation? Gabe, what do you think? Show me on your fingers, everybody. What is it, Gabe? Multiplication. All right, what if you know the total? You're not actually getting rid of them, but you're putting them into groups, but they're equal. You're sharing it equally. Leonoris, what is that?
Division.
Division. And last but not least, you don't know the total. You want to know how many altogether. You're putting different numbers. You're putting different numbers together. What is that, Miss Elena? Addition. All right, if you are at home and you have highlighters, we're going to use highlighters today for our keywords and our clues. So, I'm going to give everybody a highlighter. If you have any highlighters, yellow markers, anything like that, I want you to get it out, my friends at home. If you need one, I'm coming around and I'll get you one.
Actually, I kind of like this color. Let's bend it down.
You need your mouth.
I'm Wolverine. Wait, I don't know. Can I see your painting real quick? There you go. You got it. Purpose? Wolverine. Next back on the back.
Adrian, if you didn't get a highlighter, so you're at that right here. All right.
My highlighter is weird. Yeah.
All right. Let's go ahead and we're going to work on 2-step word problems today. So the highlighter is going to help us identify our keywords, and it's going to help us separate our first step from our second step. So go ahead and turn to page 287. Did you not get one?
Yeah, I think Can you play football that well?
There you go, bud. All right, we're gonna do an I do, we do, you do. So if you have the highlighter, follow what I highlight, and then you'll get the feel of it, and we'll know what we're looking for.
Okay.
This is Mr. Gibaldo. That's a hard name to say. Page 287. Mr. Gibaldo is baking pies and cakes for a school fundraiser. Mrs. Guys, I think I said Mrs. Whoopsie. Mrs. She bought 26 apples, 29 peaches, and a number of bananas at the farmer's market. I don't know how many bananas. She bought 66 pieces of fruit. How many bananas did she buy? Wow, that is a lot of information. Sometimes I think as mathematicians, we think we should know the answer or what to do by reading it one time. I'm a lot older than you. I've been doing math a lot longer, and I still need to read it more than once. So don't be afraid or ashamed to read it again. That makes you smart. So I'm going to read it again, and this time I'm going to use my highlighter. And I want you to do the same. Mrs. Gibaldo is baking pies and cakes for a school fundraiser. She bought 26 apples, 29 peaches. So I'm going to circle the word and, because that helps me. It's a clue for my operations. And a number of bananas at the farmer's market. She bought 66 pieces of fruit. How many, and I want to know bananas, did she buy? So, I want to know my first step. I can't figure out how many bananas she bought until I do something else. What are you thinking, Elena?
I think you get
So first I need to add 26 plus 29. Go and get your pencil. Then, can you show me where you highlighted all those? Can you highlight what I highlighted? Where's your highlighter?
Never hit it.
And then can you stack the problem? And go ahead and let's find out how much fruit we know are apples and peaches out of the 66. We need to know that first. Thank you. How did you know that?
Because it's on highlighter for a reason. And that means it's not an underline. It also has you underlined it. And it didn't say like anything about subtracting.
It didn't say anything about subtracting, but we do have an and, right? So we know we're going to figure out all the fruit first. So you got to add it together. Max Fox, can you walk me through this problem?
So 26.
So you guys need to stack it and walk through it with me.
So 26 plus 29. We can easily do this. All we need to do is take a 1 from the 6 and put it on the 9. And then we have 5 left from the 6. That would be 5. And then we add 1, 10 to the 10th place, and that would make it 5.
Okay, so he is breaking this apart to make a group of 10. He's saying if I take 1 away from the 6, that equals 5, and I add it to the 9, that equals 10. So now I know 6 plus 9 is 15, and I'm going to put that 1 there. All right, now what?
After you put
The new 10, I've got a 10 here.
2 twos, all you need to do is you just need to 2, 4, and then add a 5. And that's 1 more because you got an extra spare.
Okay, Max said you add the 2 and 2, 4 equals 4, and add 1 more and you get 5. So now I know I have 55 pieces of fruit that are apples and peaches, but I still don't know how many bananas. Serene, what are you thinking?
You can take 55 onto that on your fingers. You can say 55.
Okay, wait, tell me what you're trying to do first before you give me the steps how to do it. What number, you're counting on a what? What number are you looking at?
You take, so you count on from 55 to get to 66.
To 66. So really what you're doing
Whatever you
is you're subtracting 55 from 66, right? And you're saying you could count on or count up and just do it that way. So she knows Serena is saying she knows you're finding the difference between these two numbers, right? Because we know we have the total number of pieces of fruit, but we don't know how many of those pieces are bananas. So we have to take away the apples and the peaches to find out how many bananas there are. So you could count up 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 66. She was thinking she could count up, which would work. And what did you get when you counted up? It's a lot to count up, or you could just subtract pretty easy, right?
Yeah, 5.
What is 6 minus 5?
1, and then 6 takes away 5 again, 1.
Is 1. So how many bananas?
11.
11. So really, this is what we just did, you guys. We did 26 plus 29 with the king parentheses, right? And then we took, and then actually, I have to go back here, and I would say 66 minus that equals B for bananas. We can throw that variable in because you guys are like middle schoolers. I tell ya. Yeah, you guys know variables. To me, that's middle school. So I'm impressed. And now we know B for bananas. B equals 11. 11. That's really what you guys did. But you did it the way that you consult it and have it accurate, right? You can get the right answer. All right, but if you want to feel really smart and show off everything you know, you could write that equation out and feel proud.
I did.
All right, let's try the next one. Get your highlighter ready. Abby. Okay, Abby, it's your name. I'm going to call on you. Abby bought 8 packages of stickers with the same number of stickers in each package. She gave 15 stickers to her sister. Now Abby has 49 stickers. How many stickers were in each package? Ooh, that's tough. I have no idea. But I do have tools and I have strategies to figure it out. So a lot of you are guilty of reading it on Think Central in the mornings or in the afternoon and raising your hand. I don't know what to do, Mrs. Alvin, without having attacked it. You gotta attack it, you guys. You gotta attack it like those sharks in the video. Come after it. I don't know either. When I come sit by you, I don't know the answer. I have to think, I have to figure it out. Your brain is much younger than mine. You guys can do this. So let's use some of the strategies, Robert. What should we be highlighting?
Bought 8 packages.
Yes, I love that he said bought. That's a key word, right? Abby bought 8 packages of stickers, so she has them, right? Can you picture these 8 packages? What else? With the same number of stickers in each package. Do we know how many that is? Not yet. Nope. What else, Robert?
She gave
I'm going to help you go get that right.
She gave 15 stickers.
She gave 15 stickers to her sisters. And now what?
Abby has 49 stickers.
49 stickers. We need to know how many are in each package. Wow, this is tough. I'm going to really think about this. I'm going to read it even again. Abby bought 8 packages of stickers with the same number of stickers in each package. She gave 15. Let's focus on that because I don't know how many are in each package yet. But I do know she gave 15 to her sister. And now she has 49. So, what did she have to start with? If she has 49 now, but she had before she gave them to her sister, wouldn't I have to add that up to see how many she had first?
That's what I did.
Right? Why did you do that?
I did it because I just put the 8 to the side because I don't want to use it right now. And I added 49 and 15. And I know that 9 and 5 is 14, so I put a 4 down at the bottom and gave the 4 a 1, and that would equal 5 plus 1, which is 6, so it would equal 64.
So we needed to know how many she had to begin with before we can find out how many she has in each package. And I love what Lila said. I put the 8 to the side. I'm not using that yet. That was really smart. Okay, so we have 64 total. If she has 8 packages and they have the same number in each, what kind of, I know the total. Sunny, I think you got this. Abby, you too. I know the total. I have the same number in each. What operation? Division. So you're going to divide that by 8. So really, and that would be S for stickers. I'm going to write the fancy equation you guys just did. It would look like this. 49 plus 15 divided by 8 equals that. Look at that algebra. That's all you guys. That's what you guys are doing. Yeah.
You didn't call on me on anything.
All right. When you know the answer, put your hand on top of your head. When you know the answer. How many 8s are in 64? I can't call on Leo today. He's not here. But I can call on Haley Calendar. Haley Calendar, how many 8s are in 64? Let's see if she knows. What do you think, Haley? Where's my Haley going? All right. Jensen, why don't you share? What is 64 divided by 8? Let's see here.
That's what I got.
What's your answer, bud?
8.
Jensen Cook, 64 divided by 8. I know you know it. 8, okay. It sounds like there's a little delay or something there. Thank you, Jensen. 8 times 8 is 64. Therefore, 64 divided by 8 must equal, everybody said? 8. So S equals 8 stickers. All right. So I'm going to let you work on, we have this page plus another page. And I want to see if you can at least get done numbers 4 and 5. If you are just rocking it, you can move on to page 288. I don't know how far we will get, but I think you learn more by practicing it. So you can go to page 288 when you finish page 287. Don't forget to show your work. You may work with a partner, and if you are remote, I'm going to be putting you in your breakout room. Any questions? Okay. All right, don't forget to join your breakout room. All right, I'm going to make it clear. There you go. All right, doing your turn. Oh, thank you. Don't forget to use your highlighters.
Miss Aubin, it hasn't let us in. Miss Aubin.
I shout out to Robert and Cooper for highlighting their important words. Good job, guys. Don't forget to highlight.
Miss Aubin, we got sent back to the main scene. Miss Aubin. Miss Aubin. Aubin, back to main screen.
Yeah, I'll go out together.
You're muted.
So I'm gonna let my kiddos get back to where we were. So we were looking at page 287. Voices are up and ears are on. So we did numbers 1 and 2 together, and then I left you with numbers 3, 4, 5. I saw in some of my breakout groups they were on number 6, which shocked me because that was a lot of thinking. So I'm not going to spend too much time going over all this because of time, actually. But let me go ahead and just show you some of the things I think you could have highlighted. Taylor's reading a 340-page book. He read 174 pages of the book on Saturday and 120 pages on Sunday. How many pages does he have left to read? You could have highlighted different things, and that's fine. So in one of my breakout groups, I think it was Henry and Ben, they did it 2 different ways. There's a couple ways you could have done this. You could have said 340 minus the 174, because you know there's a total of 340 pages and he read 174. And he could have done this to find out, right, that we had 156 after Saturday. But then on Sunday he read more, 120. So now we know he has 46 pages left. Give me a thumbs up if that's how you solved it. Okay, so that's not how I solved it either. I thought that was a very cool way of doing it. Did anybody do this? Well, read 174 on Saturday and 120 on Sunday. So I'm going to add that together and get 294 pages that were read. Then I'm going to subtract that from 340 minus 294. Whoops, I'll do it up here. Just my smartboard won't let me write anymore. So I'm going to do this, and still got 46. Give me a thumbs up if that's the strategy you use. Can you sit down so they can see? Yep, okay. So hopefully you got 46 pages. You should have done 46 pages. All right, for the next one, this one was a thinker. Oh my goodness. Who can tell me what the answer they got for number 4? What'd you get? Lennox?
I got 7.
He got 7. Did anyone else get 7? If your hand is up, you are an amazing mathematician because that is the correct answer. And that one was very tough. So here's what it says. Lauren had a piece of ribbon that was 36 inches long. She cut a number. We don't know what that is, Ben. We don't know what that is. Hey, girls, please. Of 3-inch pieces. She has 15 inches of ribbon left. So first I have to see, what did she divide into 3? I have to take away the 15 that she has left. I would have gotten 21. And then I would have to divide it because she did it the same number, right? She got a number of 3-inch pieces. So that 21 should have been divided by 3, and you would have gotten 7. That one was a thinker. So wow, to all those people that got 7, I was so impressed with you. I don't know. That was tough. And then I'm just going to go to the last one because some of you did get to it. 47 students, and you're going to let me do it. 47 students in the marching band. That's how many there were. There are 5 in the first row, and the rest are in equal rows of 6. How many students are in each of the 6 rows? Well, first, I got to take that 47 and get rid of the 5 that are in the first row, right? Because it says 5 students in the first row. You should have gotten 42. Now I've got the rest of them that are in equal rows of 6. So what am I going to do, Cooper? With that 42, I'm going to divide by 6, and you should have gotten, once again, the same number, 7. All right, so show me how you're feeling about, you may close your book, yep. So let's do a quick thermometer. How are you feeling about first the properties? The properties that we talked about earlier. How are you feeling about the properties? That means distributive, associative, commutative. You don't have to have them memorized. Sit down and listen. Show me your thermometer. Thank you. You don't have to have them memorized. Just how you feeling about them, so that you can use them in your problem solving. All right. How about this two-step problem solving? Oh my goodness, this algebra you guys are doing. How are you feeling about that? I know it's tough. You have some sideways, some ups and downs. Okay, we'll continue working on this week. I know it's a thinker, but boy, you guys are so smart and you were up for the challenge. Thank you for a good job today. Mrs. Harrison's class, listen, please don't, can you listen? Put your highlighters in the thing before you take off, and I will see you guys when you're up. We will see you guys tomorrow. Thank you for working so hard. And have a wonderful evening. Don't forget Think Central. Don't forget to Think Central. It is 5.9, right? 5.9. All right, see you guys soon.